Good morning, everyone. It's Mr. Pierce. I'm going to give you a quick tutorial on reviewing, adding, and subtracting fractions. Hopefully you find it useful, and hopefully it refreshes your memory after the long vacation we've had. So when we look at the first problem and we see 4/8 plus 2/8, a failed strategy, and notice I said failed, that some kids use, is they think that you go 4/8 plus 2/8, well 4 plus 2 is 6, and 8 plus 8 is 16, and they will say the answer is 6/16. This is a failed strategy. Okay, it's not what we should be doing. When we add 4/8 plus 2/8, it is correct that the denominator must be the same. But let's put a little perspective on this. Let's say I have two students. Let's say we have Mackenzie. And Mackenzie and let's say that Gavin are going to share a pizza. Let's say that Mackenzie eats 1, 2, 3, 4/8 of the pizza. And Gavin eats 1, 2/8 of the pizza. As we can see, if we look at the total number of pieces that are shaded, there are 6 shaded. So together, they ended up eating 6/8 of the pizza. Now 6/8 will simplify. Okay, both of the numerator and denominator are even. They're only 2 apart. So we can assume that the greatest common factor is 2, which it is. And if we divide both the numerator and denominator by 2, we end up with 3/4. Here we have another problem. One thing you will notice about this problem right away is the denominators are not the same. So one way we can solve this is to use the rectangular fraction model. So what I would start out with the first one is making it so that it shows 1/2. In order to do that, I would draw one vertical line, and then I can shade in 1/2 of that. So we can see 1/2 there. In the second one, I would then go ahead and I would draw in thirds. So to make it say thirds, I would draw 2 horizontal lines. And to make it show 1/3, I would simply color in 1/3 of that. Now you will notice that these do not look alike. Okay, the first one is divided into halves, the second one is into thirds. But what we can do at this point is make them the same. We can make them have the same number of pieces. In order to do that, we can go to the second one and we can draw down one vertical line down the center. You will notice they do not look alike yet. The first one is in halves. The second one now says 2/6. But then we can also go back to the first one and draw 2 horizontal lines. Now you will notice they have the same number of pieces. So in the first one, we can see that 1/2 is equal to 3/6. And in the second one, we can see that 1/3 is equal to 2/6. 3/6 plus 2/6 is 5/6. And those two numbers are what we would call neighbors on a number line. So this problem will not simplify any further. So that was using the rectangular fraction model. Another way we can do it is, of course, using the standard algorithm. So if we had 1/2 plus 1/3, we would, of course, look at the denominators first and see they are not the same. But if you look at the rectangular fraction model, we turned them both into sixths. Well, there's an easy way to do that. If you look at the denominators, one is a 2 and one is a 3. You can always make any fractions have the same number of pieces by simply multiplying the denominators. 2 times 3 is 6. So because we know that, we can then turn each of these fractions into sixths. Okay? In order to do that on the top one, we would go 1/2 is how many 6? Well, what times 2 gives us 6? That would, of course, be 3. So if I multiplied by 3 in my denominator, I do the same to the numerator. 1 times 3 is 3. In the bottom fraction, 3 times 2 equals 6. So if I multiply by 2 in my denominator, I do the same to the numerator. 1 times 2 is 2. Now I can add those two fractions together. 3/6 plus 2/6 equals 5/6. Here's another example of adding fractions when the denominator is not the same. If we look at the first fraction, it says 1/4. So we can start out by drawing 3 vertical lines in the first rectangle. 1, 2, 3. And the second one, we can draw 2 horizontal lines. Now we can simply go in and we can shade 1/4 of the first one. 1/4 of the first one is 1/4 right there. Okay, and the second one, we can shade 1/3 of the second one. There it is. Now we will notice right away that they do not have the same number of pieces. So we can rectify that pretty quickly. We can go in and we can draw 3 vertical lines down in this one. You will notice that they still do not look the same. But if I draw 2 horizontal lines in this one, we now have the same number of pieces. In the first fraction, we see 3/12 shaded. In the second fraction, we see 4/12 shaded. 3/12 plus 4/12 equals 7/12. Again, we could do the same fraction. Okay, we could turn them both into equivalent fractions. So if we were going 1/4 plus 1/3, doing the standard algorithm, say, okay, the denominators are not the same, but if I simply multiply 4 times 3, I get 12. So if I turn both of these to 12ths, like so, we would go 1/3 is equal to 4/12, and 1/4 is equal to 3/12. 3/12 plus 4/12 is 7/12. For the next two problems, what you will notice is that they are both subtraction. I've chose to just do the standard algorithm. So if I look at these, the first problem, 3/4 minus 1/3, we will notice right away the denominators are not the same. We can simply make them have the same denominator by multiplying the two bottom numbers or denominators together. 3 times 4 is 12. So we can change each of these fractions to a 12th fraction. In the bottom one, 3 times what gives us 12? Well, that would be 4. So if I multiplied by 4 in my denominator, I do the same to the numerator. 1 times 4 is 4. In the top fraction, 3/4. 4 times what gives us 12? Well, that would be 3. So if I multiply by 3 in my denominator, I do the same to the numerator. 3 times 3 is 9. 9/12 minus 4/12 is 5/12. Will it simplify? Let's see. Factors of 5 are 1 and 5. 5 does not divide evenly into 12, so the answer to that question is no. In the second example, again, I've used the denominators 3 and 4. 3 times 4 is 12. Now, some people might think that you cannot subtract this one, okay, because they might think that 1/4 is bigger than 1/3, but it is not. Remember, the larger the denominator, the smaller the pieces. So 1/4 is actually a smaller fraction. But, as we said, the denominator for 3 and 4 excuse me, would be 12. So if I was doing this, I would go to the bottom fraction first. What times 4 gives me 12? Well, that would be 3. So if I multiply by 3 in the denominator, I do the same to the numerator. 1 times 3 is 3. In the top fraction, 3 times 4 is 12. So if I multiplied by 4 in my denominator, I do the same to the numerator. 1 times 4 is 4. Now we have 4/12 minus 3/12, which would just be 1/12. And again, that will not simplify. Whenever your numerator is 1, it is already simplified to lowest terms. In the final problem for today, you will notice that we have 3/4 plus 2/3. Again, the denominators are not the same. So we can make these have the same number of pieces by simply multiplying the two denominators together. 3 and 4 is still 12. So I can turn both of these into 12ths fractions. All right, so on the bottom, what times 3 gives us 12? That would be 4. So 4 times 2 in the numerator would be 8. In the top one, 4 times 3 is 12. So 3 times 3 in the numerator is 9. When we add these two fractions together, 9/12 plus 8/12, we get 17/12. Now that's an unusual fraction. We call that an improper fraction. An improper fraction is one where the numerator is larger than the denominator. When we get an improper fraction, we want to turn them to what's called a mixed number. So if we think logically, if I have a pizza that is divided into 12ths and I eat one whole pizza, I would eat 12/12. So 12/12 of that 17/12 would be one whole. Okay, so 12/12 is one whole. So that would leave me with 5/12 left over. So our answer would be 1 and 5/12. I hope you find this tutorial to be something that refreshes your memory. Miss Green and I cannot wait to see you in class and see your smiling faces and be teaching math with you once again. I will do another video later this week, or maybe even next week, that has adding mixed numbers and subtracting mixed numbers. So we hope this finds you well. We miss you, and we hope to talk to you soon. Goodbye.